What even is entropy? And to answer that, let's start simple. Imagine flipping 3 coins, a penny, a nickel, and a dime. Each one lands on either heads or tails. If we list out every possible outcome, we find there are just 8. Let's count them out. Now here's something interesting. There's only one way to get all heads, but there are 3 different ways to get 2 heads and 1 tail. That number, the number of different ways something can happen, is called the multiplicity, and we usually write it as the Greek letter omega. Entropy, at its heart, is just a way of counting those possibilities. The more ways there are to rearrange the parts of a system without changing how it looks overall, the more entropy it has. By the way, every specific arrangement, each individual row in this table, is something that we physicists call a microstate. And when we group those microstates by how many heads they have, in this case, that's what we call a macrostate. As you just saw, many microstates can belong to the same macrostate. That's the key idea. So when we talk about entropy, we're really asking how many macrostates correspond to a single macrostate. In our simple example, that number was small, but what happens when the system grows? Now imagine flipping 100 coins. The number of possible microstates, 2 to the power of 100, that's over a million configurations. But the number of macrostates, just 101, ranging from 0 heads to 100. So, if entropy is proportional to the number of microstates, you might think we could just say S is proportional to omega. But there's a problem. Omega grows too fast. It grows exponentially, and that makes it hard to compare systems or do any meaningful math with it. And that's why we use logarithm. The logarithm compresses exponential growth into something manageable. So we say S is proportional to log of omega. And to make this into a real physical quantity, not just a comparison, we add a constant. That constant is Boltzmann's constant, K of B. It links probability and statistics to energy and temperature. And there it is, the bridge between the microscopic world of possibilities and the macroscopic reality of heat, disorder, and even black holes.